Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Nass. I am with Embedded Computing Design, part of Open Systems Media, and I am here today with Patrick Carrier, who is a manager for secure solutions at Infineon, and Xin Chu, who is the head of security solutions at CommScope. How you guys doing today?
Good.
Doing pretty good,
Thank
Rich.
you.
Good to be here.
Thank you. It's good to have you guys because we're going to talk about security, which is, if it's not top of mind, you're making a big mistake because it needs to be top of mind for anybody involved in an embedded design, anything that's attached to anything. Before we get started, I'm guessing everybody knows who Infineon is, but I just want to make sure that the audience is familiar with CommScope. If you could just fill us in, Shin, on what you guys do and why it's significant, that'd be a good starting point.
Okay. Thank you, Rich, for having me today here. And CommScope actually is a global company that builds the infrastructure and the solution that keep our networks wired or wireless or IoT running smoothly and securely. And I am, leading CommScope Security Solutions and the PKI Center. Think of it as a place where we make sure connected devices can prove who they are and behave themselves. So I have been in the cybersecurity long enough to know the bad guys are creative. So my team works with the device makers and operators around the world, try to stay one step ahead of the bad guys.
Excellent. Very good. So we want to talk about secure provisioning here because that's key. And just to set the baseline appropriately, would you just give us a quick definition, Patrick, of what is secure provisioning?
Yeah, so I would say in more of a classical definition, secure provisioning is the loading of secure device credentials into an IoT device, for example. Now, when I say that, a lot of people think, oh, well, it's programming. It's actually a little bit different because it's not just a matter of loading software, but really it's about these sort of identities for IoT.
Okay. And why is this important? How does this lend itself to the security of the overall system?
Well, it's important.
Okay.
Oh,
Go ahead, Patrick.
Yeah, so from my perspective, I'd say it's important because it's a matter of identity. So if you had two light bulbs, for example, that you had bought from the hardware store, and they both had the same identity, the exact same serial number, and these were connecting to AWS, AWS wouldn't know the difference. Now, if you imagine an attacker, for example, they can impersonate your light bulb. They might be able to get onto your network, or they might be able to access services that they shouldn't get access to. So having these unique identities for IoT devices and securely provisioning them. In other industries for security, like payments, for example, we talk about personalization. So how do we make your credit card your credit card? In IoT, we don't call it personalization, we call it the so-called provisioning, because we're actually creating this unique identity at a device level.
Okay, so I'm going to stick with your example because it's a very simple one. With the light bulbs, whose responsibility is it to ensure that each device has a unique ID?
Okay, so this is actually this joint solution comes in, right? One that we find out is the complexity Patrick already touched upon. It's because you have different kind, like a driver's license, right? And it can be actually for drive a car or for you to drive a truck, drive a bus. So there's a complexity to deal with. What is, you can be 10 years or 1 year driver's license. So you got all kinds. So to get them also uniquely to a device, there are a lot more devices actually today than the people. So we jointly developed a solution, and the manufacturer doesn't know how to handle this, uniquely protected to a device. So we developed an end-to-end solution, so they don't have to worry about that. Basically, our joint solution is there is a client component running on the device side, make sure it's created, correctly, and then it got the proper license to put back to the device. that matches with that the secrets is supposed to never be out of the device. So, and make it sure the driver's license, when to ride the light bulb, actually the example we use here, it went to ride the light bulb to support its intended the applications. So that's, compared to, variety of the light bulbs you can have, compared to different ecosystem or different applications you're joining to, and then that can create a complexity issue and security issue, both of them, to device makers in that supply chain environment.
So at what point in the process does this occur?
Yeah, so it can happen at multiple different points there, Rich. So, for example, Infineon could be injecting unique identities at wafer level. The problem with this is that this is something that, yes, it scales very well if you're creating a lot of devices. But when you're talking about trying to meet let's say hundreds or thousands of different device makers, then that's something that, from a silicon manufacturer perspective, there is some complexities there, right? So the important thing is that the identity needs to be stored in a secure place. So when we talk about our secure elements, we're able to do that provisioning. But we're also able to enable partners like CommScope to also provide those identities and provide them in a secure way. And then we provide the location for that to be stored and the means of doing that in a secure way, in a secure environment, and in a secure chip.
So before I ask Shin how this actually happens, you said if it's a large number or a small number. Would you quantify that? What is a large number and what is a small number?
Yeah, so I would say that if you're building, let's say, hundreds of thousands and millions of devices, that would be something that when we're talking about provisioning at wafer level, that's what I mean. We provision a lot of devices all at once. When you talk about smaller devices, we see a lot of customers that we work with that they're building hundreds of thousands of devices or tens of thousands of devices. So there's kind of a gradient there, if you will. When you start getting, let's say, north or south of 100,000 or hundreds of thousands of devices, that's where that answer kind of changes, and the dynamic changes a little bit of, does wafer provisioning make as much sense or does it not, right? So and sometimes the cost outweighs the benefits, right?
So is it fair to say that CommScope does what Infineon does for smaller customers, or am I oversimplifying?
It's how about it this way? Because the IoT market is very fragmented, there are going to be a lot of players in there. So Infineon cannot possibly build so many variations of their chips to activate, to make that accessible to all the players in the market. So we kind of using PKI kind of as like when you tattoo a person, you say make same person look differently. So same hardware, but now you use PKI as kind of an identity to tell what that device can do and where they should be applied to. That creates a lot of variations. So that is the efficiency and the accessibility to the market Infineon would need, right? Infineon provide hardware, provide underlying security, but now created so many variations that are accessible to everybody in the market. That's where we come in. We have a proven infrastructure. We can get everybody on board, security, connected to anywhere, everywhere they want to go.
I don't want to make any assumptions before we move on. Would you please define PKI?
Yeah, I'll say it's public key infrastructure, Rich. One thing that I do want to add to it, maybe with what Shing said there, is that it's not a matter of just the provisioning one time, and that's the thing with Infineon as well, is we do the one time before you produce your product. When you talk about IoT devices, it's also a matter of you need identities for different services, right? So let's just say that you deploy a device in the field and you have some set services that you initially deploy it with. Over time, if you want to change or you want to add services, you want to add feature enablement later, you need additional PKI credentials to be added at that later point in time to turn on those services typically. So that's why it's really an additive service as much as a out of the box service, if you will, when you talk about where Infineon and CommScope come together.
That's a question I was just about to ask. I wanted you to talk about the relationship between the two companies and why does it make sense to work with CommScope if I'm an Infineon customer?
It's a great question. I guess I beat you to the punchline a little bit, but I would say that I think some of that comes down to I think a lot of your audience knows, at least from the Infineon point of view, you kind of introduced us and said Infineon maybe needs no introduction, and that's true. I mean, we are a leader from a silicon provider perspective in the security industry and in the security space. We're providing really the best-in-class hardware. I'll let Shing talk a little bit more about, let's say, the merits of CommScope, but that's part of why we've partnered with CommScope as well on the services side. So maybe over to you, Shing, and your perspective, right?
Sure. Yeah. So CommScope actually has a long history, and the name may not be familiar to others. I belongs to a division that comes initially with General Instrument, where we're the inventor of the digital televisions. We put a lot of security technology at the time when the content owners very strict about their security. So starting from that time, we know how to do the security to devices. So we were part of General Instrument, then we become Motorola, then in our history we become Google, and then there's along the way we have Ares, CommScope. So it's a long company history. We dealt with different device makers, deal with different chip vendors as well. So we used the Infineon in the past. So we know their capability, their top tier security, technology they have. So, but what our value brings in, because our history deal with different type of devices, and we have a proven infrastructure already in place to deal with different products, to deal with manufacturing pain points, to make sure how they get those device credentials into their, each and every device's security and uniquely. Those are the data blob you can apply to. If you use one credential, you apply to hundreds of thousands of devices, then you pretty the whole trust, like one person could have many, this or millions of people have every, same driver's license. That would be a huge problem for the ecosystem. So that's where we come in. So we come in with proven infrastructure and a very experienced staff.
Okay. I'd like for you to each wrap up with the biggest enemy that we have here. The developer who says it's too hard, it's too expensive, my design's not important enough for somebody to want to hack. What do you say to these people? Patrick?
Yeah, so I would say it's and it's easy for me to say, but there's really a lot of truth to it. We always hear I'm too small, it's never going to happen to me. It's funny enough, it's one of those where it's you think that until you make the news for it, right? So, and we've seen time and time again. I mean, there's new news stories every day about devices that you would think just why would somebody hack that? Let's go back to my earlier example of a light bulb. Why would somebody hack a light bulb? The classic example we hear from guys in the lighting space is, someone hacks my light bulb, it's going to be some kid that's just going to turn the lights on and off. It's like, well, that may be the more obvious, let's say, nuance or nuisance hack, if you will. But the reality is that light bulb is connected to your wider network. You create an exposure point for a wider scale attack if you are the weakest link in the chain or in the network. So even if you think it'll never happen to me, it may be happening to you. and you're going to make the news for the wrong reasons. We saw some hacks years ago where there was a big high-profile Target hack where they got in through the HVAC system, right? So things like that are prevalent now more and more so every day. We're seeing new and creative ways that the attackers are going after devices, and ultimately what they're trying to do is they're trying to get at things that are of value. And if you're on the same network of that other valuable thing, you don't want to be the door that lets somebody in, right?
Shin, would you address the other part about it's too hard?
Okay, yeah, I totally agree with Patrick on the security part. The trust is it's hard to build, but it's very easy to lose, right? And you can collapse if you don't do it correctly. It is hard. We don't, want to make this sound like easy. It is hard. That's why both companies get together. We put an end-to-end solution. We make it easy. We do the heavy lifting. And the security, considering security, production efficiency, compliance. So our customers, they don't have to. That way they can focus on building a great products while we make sure every device is provisioned correctly, securely, whether it's at the launch of, at the factory or years later, they need to add new credentials in the field. That's the true real value, making strong security accessible even for companies without a dedicated security team, in this very highly fragmented market. That matters to everyone. So that's why we developed this joint solution, basically to relieve some work or headache from the device manufacturer side.
And is there something coming from the two companies that the audience should be aware of?
Yeah, so I would say, quite honestly, there's you could use both solutions independently today, right? So you could use Infineon's best-in-class secure elements for various different applications. I'm not talking one specific product, but we have a lot of different products that serve different parts of the security industry for different applications. And CommScope's providing a PKI service, right? So these things are today can be used independently but together. And I would say in the future, I certainly see a future where there'll be a combined solution in the market available for any device maker that's out there that truly makes it really easy for them to manage these devices. So is there anything you wanted to add there, Shing? Or?
Sure, and I have to say one common goal for us, after we started the work with Infineon folks, we both companies see security a very important aspect of it, especially as more attacks coming up and the regulations to counter the cyber threats in the field, and that become a very important aspect. It's no longer just a feature. It could be a roadblock to, for you to get even into the market. So we both think security is a very important aspect for connected world in the future. So we try to provide complementary security services that not only provisioning, we have how to secure software download, how to prevent the software supply chain vulnerabilities by software scanning capability we can provide. So there are a lot of the security services we think we can work with Infineon, unlock that security potentials Infineon chip values they can provide to device makers.
Awesome. Thank you very much, both of you. This has been very educational, and hopefully the audience takes heed of this.
Well, thank you for having me today.
Thanks, Rich.
That was Shin Chu, the head of security solutions for CommScope, and Patrick Carrier, the manager for secure solutions at Infineon.
Thank you, Patrick. Too.